Welcome back, everybody. Take your seats, please. Thank you for bearing with us on the temperature. I think I heard a 0.4 dB rise in the fans during the last talk, so the hotel are working on it, so thanks for bearing with us. And that just leaves me to introduce Joe and John from Sweet Justice, who are going to talk about the Ascent.
Yeah. Right. Thank you.
Check. Everybody hear me? Yep. Okay. So yeah, my name's John Tennant. I'm a senior technical sound designer with, thanks, Joe.
That's all right.
Very pro. I'm a senior technical sound designer with Sweet Justice, and my colleague.
Yeah, I'm Joe Thom. I'm a technical sound designer at Sweet Justice and the lead environmental sound designer on the Ascent.
And so today we're going to talk about some of the best and the worst technical sound design systems that we put into the Ascent. I wanted to show you some of the good stuff and some of the bad stuff, just so that we can all suffer together. So to start it off, we're actually going to play a little bit of a long video, and it's by a chap named Stefan Rutherford. He did all of the weapons and combat sound implementations, and so this presentation really wouldn't be complete without covering some of the weapon systems, and so he couldn't be here, and so we get this video instead.
Hey folks, I'm Stefan Rutherford, one of the sound designers working on the Ascent. My focus is on the combat sandbox of the game, so John's asked me to talk a little bit about how I set up the weapon fire events in the Ascent. The goal here was to have a setup where I didn't have to do unnecessary or additional changes inside of Unreal beyond the initial setup on the audio's gun component, which is shared by all weapons in the game. The first thing to note is that we only have 3 events for the entire game. We've got a play weapon fire loop, stop weapon fire loop, and a play weapon fire single. And those are set up on the shared gun component here. And we've got a few events. So we've got things like event on fire pressed. We check if it's an automatic weapon. If it is, we then trigger the play weapon fire loop. And we've got on fire released. Again, with those checks, we'll stop it. And on fire single here. And obviously with only 3 events, we need to pass all of the data that's necessary to the weapons. So that includes what weapon it is, fire rate, the environment it's in, what direction it's firing, all this sort of stuff. And we wanted to respond to all of that. So if we look at how we set the switch, we basically get the weapon type as a string here, which uses the gameplay tag of the weapon. The designer that creates the weapon would create that gameplay tag, and as you can see here on the dread we're looking at, they would add that gameplay tag. So I wouldn't even need to open this. I could just ask the designer once they'd created a weapon, it would be in a Jira task, whatever, and then I just add that to the switch in Wise. We can jump over to Wise and we can see that here. So if I look at this one here, for example, this is the towards me sound, so the sound when the weapon is firing towards Blair. We can see I've added the dread in there, just like you would with any switch. And so, yeah, that means that I can just add my sounds, build, test nice and quick. Another element that I wanted to reduce any additional work on was fire rate. So often a gameplay designer will change the fire rate for a weapon due to balance reasons, wanting to change the feel of a weapon, all sorts of reasons. And I didn't want to have to change the sounds for looped weapons every time that happened. So we set up parameters for that. So if I look here, we have a duration, which sets the speed of a random container's continuous play mode based on trigger rate. So again, the designer would say, okay, I want to change the fire rate. So maybe originally it sounded like this. And then for whatever reason, they might decide that they want to speed that fire rate up. So they could change it like this. Or slow it down and so forth. So that gives you an idea of how we had fire rate automatically adjusting. Another element that we had was whether you were inside or outside. So we can look at an example of that here. Again, that's sent through as a parameter. Let's try the energy rifle here. So imagining we're inside, it would sound like this. And then perhaps you move outside and it would sound like this. So you can hear we're going for authored content on these rather than using the in-game reverbs to give that sense of environment, just so I can do fun things like pull out specific elements you heard in the Tales of the Exterior environment. I want to get that kind of laser bouncy sound of echoing lasers, so I make those more exaggerated and all that kind of thing. Another thing that we have reflected in the weapons is the direction they're firing, so whether it's towards the player or away from the player. So here's an example in game of that. There are instances in the game where you come across groups of enemies and a lot of them might be using the same weapon. In order to counter that, what I did was set a pseudo-random parameter on each of the enemy's weapon audio components, and then inside of Wise, I selected different sets of sounds, and within those sounds, I set the bass pitch for those weapon fires as well. What I'm going to do now is show an example of that. I'm going to spawn a bunch of guys with pistols, and you should be able to hear how each of them have slightly different weapon fire sounds. Thanks everybody for listening to my little mini talk about weapon fire sounds and some of the features we added there for the Ascent. Good luck, Joe and John, on the rest of the presentation. Sorry I couldn't be there, and I hope everyone's presentations go well. Thanks, bye.
Thanks, Stefan.
Thanks, Stefan. Yeah.
Hey folks, I'm Stefan.
Okay. All right. Yeah, so obviously in the game there's lots going on. There's lots of voices, and there are a lot of act components instanced in the game, and so I'm going to talk a little bit about the system that we use to control that situation. Before we did this system, even in scenes without combat, we were clocking around 1,300 separate act components, all ticking at frame rate, and this was the primary draw on the FPS for the game. And so we really needed to put a system in quickly to control this situation. And so the first iteration of the system, we basically just sorted all of the Wise events into two categories. And the first category was like the excluded group, which meant that the system didn't affect the way these Wise events played back at all. And the second category was the default group. And the Wise events that are in the default group would be controlled based on a maximum range that was tunable and also a max limit allowed in the group. And then if a Wise event wanted to instance an act component into the default group, and that default group was already full, but the act component is closer to the player than something that's already playing in the default group, then it would take that act component slot and play the new act component instead. The second version of this system basically looked a little bit like this. We added new scope groups as they were needed, and we tried to keep them as vague as possible so that they could apply to as many things as possible. So you can get a sense of what we were doing there. I mean, the critical shared weapons group was kind of the meat of it. We added that one last, and we only put the most critical like combat sounds in it, and that was basically just to kind of reserve a bunch of act component slots for combat, to make sure that we would never hear a combat sound get taken over by, say, like a ship flying overhead or something like that. Yeah, short range spots, that was another one, but we realized that there were so many so many different like small sounds, like the buzzing of a neon light or a television set, or like something from the Capsule Hotel, or there were just so many of these things that were only meant to be heard from a very short distance away. So it didn't make sense for those ACK components to be taking up slots in the default group. So we made a very, very short maximum range on the short range spots, and then dumped a bunch of sounds into that, and that saved us a ton of ACK components. So I've got a little demo here of kind of what the scope group system kind of sounds like when it's abused. And so what you're going to hear is the critical shared weapons group, or the combat scope group. And in the video, it starts at 16 ACK components as the maximum limit, which is how the game shipped. And then I bring it down to, I pause the game and I bring it down to 3, and then I pause the game and I bring it down to 1. And then at the end, you'll see me like firing the gun a bunch, the player gun, so you can see how even with the critical shared weapons group at only allowed 1 ACK component at a time, you can still hear the player weapon. It actually sounds a lot better than you think. It's not so bad. So let's play this. Did I? Sorry, I paused it by mistake. There we go. So now we're down to 3. So the system's pretty dynamic. You could still mostly hear everything. A little bit of clipping going on. Now this is what it sounds like when it's 1. So obviously 1 ACK component is completely unacceptable. It can never ship like that. But it's illustrative to show how the system works and how quickly it swaps between the ACK components as new ones are instanced. So the result of there. So the result, yeah, we had this problem of about 1,300 ACK components at a time, and we reduced it down to 80 or 90. And it was always a floating range because there was always those WISE events that were in the excluded group, and they could stack up. And usually we had a target of around 10 of those allowed max, but we didn't want to actually limit them because of the nature of the sounds that were in that group. And then on the min-spec platforms, we reduced it even further. We had settings that were specific to min-spec platforms to help get the frame rate better on those platforms. And so, yeah, this is obviously one of the systems that we're proud of. So, and Joe, you're up.
Cool. All right, so I'll talk a little bit now about how we approached a lot of the environmental design and a little bit of the implementation as well. We had a whole range of different kind of challenges when it comes to implementing the environments for the game. The main one being that the environments that the game takes place in on Velez are extremely kind of detailed. There's a lot going on in the world, and it was far too much for us within the time limit to ever be able to accurately add sound for everything. And possibly more so than that, we might not have actually wanted to do that anyway, because it just wouldn't have sounded right if we tried to make everything that's happening in the environment at all times make completely accurate sounds. Another issue was players tend to move pretty quickly from A to B, or as fast as they can. So we wanted to find a way to get the kind of almost washy, cyberpunky aesthetic that we were going for across to the player in a way that it didn't matter if they were just darting through the world, so we could still translate the environments to them. We wanted to tell our own stories off screen. So we've got a ton of, I mean, I'm sure we all know here that a lot of sound is talking about what you do when it's not on screen and kind of adding things on in the background that you don't necessarily see. So, but we wanted to tell our own stories through that. And lastly, we also wanted to implement a way that we could have single-use fire and forget sounds, and we could implement them at any time. So once the player's heard that sound once, they'll never hear it again. And we generally wanted that to be on entering new environments, a bit of a kind of reward kind of stinger or something like that. So we came up with 3 separate solutions. The first one being micro stories, which are stories that we tell in the environment that can be, anything like a fight happening in another room off screen, or people watching cartoons in the next room over, stuff like that. And we had hundreds of these. What became known as pass-by environments, which was us using very kind of evocative, kind of broad brushstroke, almost just tones in the environment, rather than trying to sync everything to individual movements. We wanted to paint a kind of synthy, cyberpunky picture with literally just using tones and not trying to sync too heavily to anything in the environment. And the last one we called environmental stingers, which were these used once sounds that the player would only ever hear once. And that was, like I say, generally upon entering a new environment. So the only real techie thing in this was how we set up the environmental stingers, where we created a new blueprint actor, which was essentially just a volume that we could place anywhere in the world. But when that volume was spawned whilst playing the game, the first thing we'd do is check whether it's actually been used or not. If it has been used before, we'll deactivate overlaps on that volume, so when the player overlaps it, nothing happens at all. If it hasn't been used, then we'll activate overlaps, so when the player crosses over the volume threshold, we'll essentially just very simply play a sound, and then we'll go through this custom C++ node to essentially save a used state to this actors GUID in the player save file. So that just gave us the opportunity to add single-use sounds anywhere we wanted in the world, which was really nice. So I'll just give an example of a few of these things now. The first couple of clips will be kind of pass-by environments that we can hear going on. I've got a couple of kind of micro stories that we tell off screen. So here we've got a fight happening in the next room in a casino in the VIP area, complete with bull whips and Hollywood Edge style sounds. And here we've got a capsule hotel with aliens watching cartoons and talking on the phones inside the capsules. We've got a little kind of pass-by micro story of this little tugboat with a couple of guys having a party on it, with one of our very own John Tennant's tracks playing in the background. And lastly, we've got an environmental stinger here, so this is a single-use sound upon entering a new area. So with those kind of free solutions, we can, the environmental stingers we can use to telegraph the kind of feel or the situation that the player's entering into in the next area. We often use that to kind of give a little indication of what's to come. So if you're entering a particularly dangerous area, maybe we'll play like a gunfight off screen or something coming from the distance, all sorts of stuff like that. And pass-by environments allow us to add these kind of tones, these kind of broad brushstroke tones to give the feel that we want to a certain area without having to meticulously sync to various things. And then micro stories, just we get to tell our own little stories in the world, which is a fun thing to do. There we go.
Yeah, so as promised, this is one of the sort of questionable implementations, and it's mine. Yeah, so I was trying to hook up. If you click, will it play? Trying to hook up this sound. It's just a computer hacking sound that the player crouches down and is hacking a computer. But the problem, the issue with this was that it was using the same animation that's used for Revive Teammate. And the event itself is a code-based event. And Revive Teammate is also a code-based event. So we couldn't get to the core of it. So usually when you can't get to the core of it, you'd maybe like duplicate the animation and then tag one of the animations, something like that. But it was code-based. We couldn't duplicate the animation because we'd have to ask a programmer to hook it up. And the programmers at this point, I think we were like maybe 2 months out or 1 month out from shipping, and the programmers were like not having any of it. None of this was on their radar as something that they wanted to spend time doing. They were busy fixing way more important bugs. So like in summary, what we needed to do is to trigger a WISE event on the animation, but only when the player is interacting with this BP interactable computer blueprint. So here's the train wreck that I put together. On the player animation blueprint, whenever the player went down into a crouch, I did a get all actors of a class. And so that would pick up all of the computers that were loaded in the level and dump them into an array. And then
it's loaded in like 3 levels, right? With the
there's a lot, yeah.
Okay.
And I dumped them into an array, and then I did a distance check on all of them to see whether any of them were within 3.5 meters of the player. And if they were, I decided, well, they must be interacting with a computer and not reviving a teammate, even though it's totally plausible that they could be reviving a teammate within range of a computer. But, it is what it is. You kind of do what you need to do to ship the game. So, what's the big deal? What's the big deal with this? So the crouch anim state is used a lot, and it's used most during heavy combat. So every time this was used, it fired off this get all actors of a class, which is not performant. And then after that, it did a for each loop on the array, which is also not performant. Of course, the better way of doing this is to do it with a blueprint interface, and that's how it's set up in the game now. It did ship with my implementation originally, but then when I went back to look for it to get a screenshot of it, someone had fixed it, and I'm pretty sure it was Roger, and he fixed it without complaining to me. So I really thank Roger for not calling me out on Slack about this one.
All right, so whilst we're airing our dirty laundry, I guess I will talk about some of mine, which is we have a sequence in the game that takes place in a nightclub called Dreamworld. And it was very important, not only to ourselves, but also to the folks at Neon Giant, that we synced up the music really nicely to this big like cutscene event and then this big fight, and it was really cool. So we kind of got there. It ended up like this.
Yeah. Compromised. When? Understood. Someone just came in, matched the description. Yeah, I'll handle it.
Everyone, your attention, please. Onyx Wide will pay a considerable sum for the head of the individual who just entered. No need for it to be attached to anything. Come see me when you're ready to collect.
So kind of works. But what was the problem? So music drop has to sync nicely with the start of combat. That's fine, but the problem with that is the cutscene can be skipped at any point if we want to, so we still need to make sure that drop hits if the cutscene's skipped. The intro, when you stood in the entrance lobby, needs to loop indefinitely, and then after that, combat music needs to loop indefinitely as well. And I like your excuse about the programmer stuff, so I'm going to go with that as well. No programmers at all at the time. So we had to separate this completely from our music system that we'd set up for the entire project and kind of implement it as a kind of individual system. So we split out the intro loop segment, which would loop indefinitely as you're as you're standing in the entrance hallway. Then within a switch container in Wise, we place the cutscene event, which is cut nicely to sync along with the cutscene with the lyrics and everything, all the big build-up. And then we have another section, which is sequence container, which contains a small kind of lead-in transition event, and then also the looping battle music that comes in afterwards. And it kind of worked. It syncs afterwards and everything, except it actually still didn't work at all. And I'm going to pass over to segue nicely to John to explain why that didn't work at all.
So I got this Jira bug. The Dreamworld sequence doesn't work on client, and I knew that I was going to have to pull this replication trick that I've used on a few games now out of my back pocket and try and make it work on this game. And so I've used this trick on Gears of War 4, 5, and Returnal, and now on the Ascent. I've yet to get a complaint about it from a programmer, so I guess that's good. So I'm going to show you how it's set up. This will be helpful for anyone who's trying to deal with replication. So what's replication? You've got a sound that's playing, that's being triggered on one side of the network, but not on the other. And it's usually always, it's triggered on the server, but not on the client. And so oftentimes the reason this happens is you have some blueprint script that's only running on the server side, but not running on the client. And so how do we get the client to pick up these events without setting the client up to run all of the blueprint script? That's the question. And do we go through these blueprint scripts and set all of them up to be multicast, all the blueprint events, and set them up to be multicast reliable? We get in a lot of trouble from programmers if we did that. So this is the solution that I came up with instead. So I made a blueprint component that had to be called the ACK event replication station, obviously, and it needed to be hosted somewhere in the game by something that is always persistent. And the thing that is always persistent in an Unreal game is the game state. And so this blueprint component lives on the game state. And the events that are set up in this blueprint component are set to be multicast and reliable. And so we use the audio functions library as a place to create a function that's basically a wrapper for this whole system. And this is kind of what it looks like. So the name of this function, if you can't read it, I'll read it for you: post force replicated ACK event. And then you've got an input for an actor and an ACK event there. And that's just translated all the way over there to the right. But what I'm doing here is to get the game state, cast the game state to something I can interface with, and then from that pull the blueprint component, the act event replication station, and then fire off this event, which is hosted by that blueprint component, which is rep post buys event, and rep stands for replicated. And then in the blueprint component, the replication station blueprint component, it just looks like this. It's really simple. It's just you have this event, and it's set to multicast, and it's set to reliable, and it just passes the act event and the actor, and then just does a regular old vanilla integration post wise event function. So basically, if you instance this function on top in any blueprint, regardless of whether it's set to run server side or not, and you fire off an event with it, it will also fire off on the client without having to modify the original blueprint, which was the problem in the first place. So it's just kind of a hacky trick. You're just calling this, you're using this one spot on the game state, which is always there, to host replicated events. Yeah, so didn't use it a lot in the game, but I counted, and it was about 20 times for the 2D version of the event in the entire project, and about 10 times for the 3D version of the event in the entire project. And I think about, like, of those 30, I think 25 of those were used in the Dream World sequence.
It's not my fault.
It's not. It's definitely not Joe's fault. But yeah, and that's what the events or what the functions look like when they're instanced in a regular blueprint. And yeah, it's a decent system. It's been working well for a few games now, and no programmer has come knocking at my door about it. I think maybe the one reason I'm getting away with it is because it kind of focuses all audio replication to a single point where it can be debugged and monitored on this one blueprint component. So it's got that going for it. So there's a lot of control there. Yeah, I hope to use it again.
All right. There's a lot to go through with mixing. We could probably do a whole one of these just about that. And I've definitely got to shout out Sam Justice and Stefan Rutherford as well for helping to put all this stuff together. But I'm going to start with just a quick video. And this is a video of the Sweet Justice grenade, thus named because the grenade was actually built by Neon Giant to make room for a concept sound that we made, and they decided to call it the Sweet Justice grenade, and that's pretty cool. And it also gives a bit of an example of some of the more extreme kind of mixing that we implemented in the game. So that was some of the more heavy kind of mixing and ducking. But before we explore that further, the main issues are there's a lot going on. So, you know, we can have 30 plus enemies on screen, all making their own cool bangs and swipes and gunshots, and all competing for attention. We have a lot of cool music in the game, both the OST and we licensed a bunch of tracks as well. So we need to make a lot of space for that sometimes when we want to hear it. And as we kind of touched on a bit earlier, we've got very kind of detailed environments that at times deserve to have their own kind of space in the world as well. So we started to referring to this as kind of rubber band mixing or spaghetti mixing or, you know, however you want to put it. But that's essentially, you know, putting rubber bands around several faders on a mixing desk and making one thing affect another. And really everything here is affecting everything else. We're using 300 plus Wise meter effects, and they're controlling 96 mixing and mastering RTPCs at all times in the Wise project. In addition to that, we've got over 100 location-based states that we're using. So every location in every map in the game has its own state that's being passed to Wise, and we do the same for mission steps as well. And then just very simply, we have the kind of game state of just exploration and combat. We experimented with stuff like, you know, spotted by enemy or suspense states and stuff like that, but it just wasn't necessary in the end. So we've got a little example of a couple of the buses here. So this is how we start right at the kind of content creation stage, right at the authoring stage. We're starting with mixing. So we're splitting out all of the assets. So right here, we're looking at the player weapons. So we're splitting out the body and the tail and everything like that. And we're using these separate buses to duck multiple other things. And we're also doing this hierarchically as well. So we've got medium explosions ducking small explosions, large explosions ducking medium explosions, simple stuff like that. But then what we're kind of showing here is we've also got things like the fire body of a player weapon might duck all of the weapon tails of all of the NPCs, or the initial hit of a weapon fire will duck all the explosion tails. So we're taking out these noisier elements at all times, and the less important elements that we don't need to hear are always being ducked by the more important stuff. And that's all pretty standard, pretty simple stuff. What we're doing here, just for an example, is the top RTPC there was the active enemy count. So at all times, we're counting how many enemies are engaged with the player. And we're using this to do a whole number of things. So here, what this is doing is whenever there's X number of enemies present and engaged with the player, we're attenuating all of the tails of the player weapons. So if we've got 12 enemies shooting at us, the last thing we need to hear is the airy kind of tails of our own weapons. So we do that a lot with a bunch of different parameters. Next thing that we do, this is an example of how we actually limit how many instances of a sound can be played through any particular bus. So again, we're using the active enemy count here. But what we're actually doing is if there's 9 or more enemies present and actually interacting with the player in combat, we actually start limiting the amount of enemy weapons that are allowed to be played through the bus at a time. So if there's any more than 9, we actually limit that to 1. So we can only ever hear 1 enemy weapon at a time. And that seems kind of counterintuitive. If there's more enemies, you should hear more things going on and more weapons. But what we actually found was it's much more important to be able to pinpoint exactly where all these weapons are coming from and to have a really nice, clean mix. So the more enemies that are there, the less we actually want to hear. And what we'll do is use that same RTPC to actually fade up a 2D ambience. So we really strip back on the individual weapon shots, but then fade up a chaos layer, which is authored content of high-pitched ricochets and pass-bys, stuff like that. And that's
Ambience.
But that allows us to reintroduce a bit more of the kind of frenetic kind of chaos of battle, but without actually deducting from the pinpoint precision of where all the actual weapons are coming from. And we can offer that content to be, so it's not muddying up the mix or anything like that. So we found that worked pretty well. And just got an example of some of these systems here.
Sorry, buddy. OB found our location and they're twisting my arm hard. How to do this?
little things in there that we didn't mention as well. First of which being the kind of laser ability at the start, which actually uses the same bus as the Sweet Justice grenade, which is essentially our cool stuff bus. Any time we thought something was awesome, we'd put it there, because why not? Like it sounds cool, and yeah, you can try and make it sound real or whatever, but at the end of the day, it's a laser that's firing out of someone's hand. So it's like, it sounds cool, why not? We'll just make it duck everything else and be awesome. Then also we have the towards me sounds that Stefan mentioned a bit at the start. You could really hear that on the flamethrower at the end. That was just another example of that. And lastly, fairly sort of right at the very end of the video, we have a post-battle sweetener that we'd play. John just told me this, I didn't know this, but apparently it's based upon the amount of experience that the players earn within the last 10 seconds. And if that's over a certain level, we'll play a post-match sweetener, which is quite literally like the dust settling after a battle.
It's like that scene from The Matrix, when
exactly.
the pillars are all falling apart after the gunfight.
Yeah, totally.
Except it's in our game.
So yeah, we can have the ability to easily isolate important sounds that we want to hear all the time, give focus to our stylized designs or the licensed music that we've got, and the states that I mentioned earlier with the for every map location has a state and every mission step. That proved invaluable towards the end when we're mixing the project, because it meant at any time we could jump in, select a single sound or a whole category of sounds in Wise and just say, we had it there already set up. Whenever I'm just in this specific location, turn this whole group of sounds down by X amount, which makes it so much easier to mix. So that really helped a lot.
This is the most important slide. Thanks so much for having us come and speak. And of course, this game came together, but it was a huge joint effort. And we have some of the Sweet Justice sound designers here in the audience. If you guys want to stand up, please.
Hey,
come on.
Hey.
Fantastic. Thank you so much, Joe and John. Fantastic talk. And I can actually recommend the game. I've been playing this for a couple of weeks now. I've been into it. Yeah, it's really, really good. I highly recommend it.
Thank you.
With regard to questions, maybe if people have got burning ones, they could possibly come up. But Joe and John are also going to be on the open mic panel as well. Thanks for staying behind and doing that. So little break. See you in 15.
Sweet.
Great.
Thank you.